In this video, I will walk you through free response question number 2 from the 2015 AP Calculus exam. This problem is calculator active, so we will be using our graphing calculator as needed. This problem is primarily about area and volume. Let f and g be the functions defined by f of x equals this function and g of x equals this function. Let R and S be the two regions enclosed by the graphs of f and g shown in the figure above. Part A. Find the sum of the areas of region R and S. We know that if you integrate with respect to x, you can find the area between two curves by integrating the top function minus the bottom function. Notice that for region R, the red function is on top and the purple function is on the bottom. And then for region S, it reverses, and the purple function is on top and the red function is on the bottom. For that reason, for the sum of the two areas, we will have to add two separate integrals. Let's type both of these functions into our calculator. I am going to enter f of x as y1, and I will enter g of x as y2. So let's hit the y equals button and type in both functions. Before I hit that graph button to take a look at what we've got, I would like to adjust the window to make it more closely resemble what we see on the AP exam. So look at the x values that they give us at the extremes. On the left, it starts at 0, and on the right, it's going to 2. So let's adjust the window so that the minimum x value is 0, and the maximum x value is 2. So how about those y values? Well, I don't exactly know what the highest and lowest y value is. Probably the highest y value is this one, is here at 4. I see a y value here at 2, but this is lower than that. So maybe I'll just leave my window between 0 and let's say 5. So for the y min, I will say 0. And I'll put 5 for y max. So let's take a look. Soak it in. The colors will help me determine which graph is f of x and which graph is g of x. But I better look back at my y equals. So y1, which is f of x, is red. And then y2, which is g of x, is green. So let's look at that graph again. So the red graph, the bottom graph, is f, and the top graph is g. So here I've changed the colors on my graph to match what's on my calculator. I need to know what the x value of this intersection point is so I can set up the limits of integration for this problem. So back to the calculator. If I want to find this intersection point, I want to hit second trace and use option 5 for intersection. Where it says first curve, just make sure the pointer is close to the point of intersection and hit enter. Second curve, you can just hit enter again. When it says guess, you can just hit enter again. So this is the x value of the intersection point, 1.033 if you round up. I actually want to store this into a letter on my calculator. So I'm going to store this into letter B. You can store it into any letter you want, but the way you do this is quit your way out of here. So I'm going to hit second quit, and I'm going to type the x for the x value, and then store, because I want to store this x value into something, and I want the letter B, so I'm going to do alpha B. So I'm storing the x value in letter B and hit enter, and here it is. Now all of these decimals are stored into letter B. So when I integrate later, rather than typing in all of these numbers, I can just type the letter B. So that'll be much easier. But we need to record this in our work. So 1.033. So in our work, we need to write B equals, B equals 1.033. All right, that must be included in our work. So now we will write an integral for the area of each region, and we will add them up. So let's start with region R. Remember, we are integrating the top function minus the bottom function. So for region R, the limits of integration will be from 0 to b, all right? Because that's where region R begins and ends. So 0 to b. And we are integrating the top function minus the bottom function. So in this case, that will be g of x minus f of x. And please just write g of x minus f of x. You do not need to fill in these ugly expressions. They have already been defined as f and g. So just use f and g, g minus f. So this is the area of region R, but we need the sum of both areas. So now we will set up an expression for the area of region S. The limits of integration will be from b to 2. That's where region S begins and ends. So we will integrate from b to 2. And again, we are integrating the top function minus the bottom function. In this case, the top function is region F, and the bottom function is g. So this time we will do f minus g. So you're looking at an expression for the sum of the areas of regions R and S. All we have to do now is type this into our calculator. And if you used my shortcut of storing the value of the intersection point into letter B, when you type it in, you will literally write letter B. If you don't like that, then you need to type in the number manually. But please remember, you can't just type 1.033. That's rounded. If you're going to type it in manually, you have to type in all of these numbers. One more thing before we type this into the calculator. Please remember that I entered f of x into y1, and I put g of x into y2. So when I put this in my calculator, when I type g of x, I will actually type y2. So this will be y2, and this will be y1, and this will be y1, and this will be y2. That's how it will be typed. So here's how we do it. To integrate, you hit the math button and choose option 9 for integration. We are integrating from 0 to b. So I'll put 0 and alpha b. For this first one, we're doing g minus f. That's y2 minus y1. I can access y2 by hitting the vars button and switching over to y-vars and just hit enter for function. So I want y2, so I'm going to pick y2. Now I need minus. Now I'll repeat that process. Vars, y-vars, enter, and this time I'm choosing y1. So I've got y2 minus y1. That's g minus f. Okay, I'll just finish that out with a dx. And this is the sum. So I'm going to put a plus and repeat. So math 9. This time I'm integrating from b to 2. So I'm going to do that alpha b and the 2. And this time I'm doing f minus g. So this will be y1 minus y2. So again, vars, y-vars, enter, y1, minus vars, y-vars, enter, y2. And that's it, people. 2.004. Always write your answer in a sentence. So the sum of the areas of regions R and S is 2.004. Part B. Region S is the base of a solid whose cross-sections perpendicular to the x-axis are squares. Find the volume of the solid. When they say that region S is the base of a solid, I want you to picture an oddly shaped loaf of bread that is sitting on region S. Region S is the footprint of this weird bread, and we are looking down on the loaf from above. Imagine that this blue segment represents one slice of the solid. We can calculate the volume of this solid by adding or integrating slices like this one. It's a three-step process. Step 1 is to write an expression for the length of the base of a single slice. So if this is a slice, now just imagine that this segment represents the length of the base of a single slice. If the slice is vertical, you can find an expression for the base by subtracting the top function minus the bottom function. In this case, the top function is f of x, and the bottom function is g of x. So an expression for the length of the base will be f of x minus g of x, the top function minus the bottom function. Step 2 is to write an expression for the area of a single slice. Remember, we are told that these cross-sections or slices are squares in this case. So we are looking down at this solid from above. However, if we pulled out a slice and looked at it, it would look like this. So here is the base of the slice that we were talking about on the previous step. And I'm just going to call this B for a moment. If the base of the slice is B and the slice is a square, well, the area is going to be B squared because it's a square. So if the base is B, then all of the sides are B. So the area is B times B. So in this case, the area of a single slice is going to be B squared. And look, in the previous step, we wrote here in blue an expression for the length of the base. So f of x minus g of x, that's the base. If I now want to write an expression for the area, and I know that the area will just be the base squared, I can turn this into an expression for the area by just taking the base and squaring it. So now I'm looking at an expression for the area of a single slice. The last step is to write an expression for the volume by integrating the area. When you integrate the area of a single slice, you are adding up all of the slices to form the volume. So since I already have an expression for the area of a slice, all I need to do to form the volume is integrate. Since these slices are stacked up between, remember this is at location B, all right, an x value of B. So these slices are stacked up between B and 2, then those are the limits of integration. Whoops. B to 2. So let's put this in our calculator. As we do, please remember that I entered f of x into y1 and g of x is into y2. So I will integrate y1 minus 2 quantity squared. Again, for integration, we hit Math 9, and we are integrating from b, so alpha b, to 2. Now, be careful. We are squaring y1 minus y2. So I'm going to need some parentheses in here because I need to square later. For y1, I'm going to hit vars, y-vars, enter, and y1, and then minus vars, y-vars, enter, y2. Now close the parentheses and square it. And that's it. 1.283. Writing our answer in a sentence, we have the volume of the solid described is 1.283. Part C. Let h be the vertical distance between the graphs of f and g in region S. Find the rate at which h changes with respect to x when x is equal to 1.8. Wait a minute, they're talking about the vertical distance between f and g in region S. I'm having deja vu. Weren't we just talking about the vertical distance? This blue segment, which I was referring to as B, because it was the base of a single slice, this is the vertical distance between f and g. And we found that distance by subtracting the top function minus the bottom function. And we found that it was f of x minus g of x. So just instead of calling it b, they're now calling it h. So let's just copy that down. So h, the distance between f and g, will be the top function minus the bottom function. So f of x minus g of x. Find the rate at which h changes with respect to x. The rate of change of h. So are you hearing the derivative in that? So if we want the rate of change with respect to x, that will just be dh dt. We're talking dh dt. That'll be dh dx. Okay, it's not with respect to time. They specifically said with respect to x. So dh dx. So how do I take the derivative when the function has two terms to it? We can just differentiate term by term. So this will simply be f prime minus g prime. We specifically are to evaluate when x is 1.8. So in other words, we want the value of dh dx when x is equal to 1.8. Well, we have this expression for dh dx. If we want to evaluate at 1.8, that means we need f prime at 1.8 minus g prime at 1.8. Great news, the calculator will do all of this for us. Just remember, as I show you what I'm about to show you, that f is y1 and g is y2. Just keep that in mind. So we need to do f prime at 1.8 minus g prime at 1.8. So let's start with f prime, which is in y1. So here's how you do this on the calculator. Hit the math button, and for the derivative, we're going to choose option 8. So we're using this format, the ddx. So we're going to do the derivative of f. Okay, so this will be f prime. But again, instead of f, I'm going to put y1. That's where we have it typed in. So I will hit vars, y vars, enter, and y1. So this is f prime. And if I want to do f prime at 1.8, this is where I type in the 1.8. So this is now f prime at 1.8. And we are supposed to subtract this minus. So I'm just going to, I hit the right arrow key to get out from the 1.8, but I'm just going to go ahead and do minus. Now I need g prime. So I'm going to go back to the math button and choose option 8 for derivative. Put that dx. Now this is function g, the derivative of g, but g is in y2. So I hit vars, y vars, enter, y2. So this is now g prime, the derivative of g. And this is also at 1.8. So that's it. Just hit enter. Negative 3.812 if you round up. You're allowed to truncate, so the College Board will also accept negative 3.811. There are no words that we need for this final answer because these symbols express all of the words we need. The rate of change of h with respect to x when x is 1.8 is equal to f prime at 1.8 minus g prime at 1.8, which equals negative 3.812.